In video 2, we're going to find inverses of functions instead of just inverses of relations like we did in video 1. So now we're going to look at equations and find the inverses of equations. Step 1 is to use the horizontal line test to decide if the inverse is a function. If the inverse is a function, or if it is one-to-one, then you're going to follow the steps below in the little box. If the inverse is not a function, you're just on MyMathLab, you're going to click whatever says the inverse is not a function, the f of x is not one-to-one. Any of that means we are not going to take the time or the steps to find or decide what the equation of the inverse is. Determine whether the function f of x equals 1/2 x plus 5 is 1-to-1. If it is, find a formula for f inverse of x. If it's not, we're not going to find the formula. So the first thing you can do is, since you have a graphing calculator right now, I will just let you use that. You should know this is the equation of a line. Anywhere you're going to draw a horizontal line on this 1/2 x plus 5, it's only going to touch it once. But if you want to see that, you're going to go into y equals. Now, I already have mine here. I have 0.5 x plus 5. So I'm going to go ahead and graph it. There is our 1/2 x plus 5. Anywhere that you draw a horizontal line on this function, then it's going to cross the graph exactly one time. So this tells me it passes the horizontal line test. So the inverse is a function. Again, passes the horizontal line test. So that means f inverse of x is a function. And it also means that f of x is 1-to-1. So now that we've decided that, we're going to go ahead and find the inverse of the function. So let's look at these steps up here. It says obtaining a formula for the inverse. If a function f is 1-to-1, a formula for its inverse can generally be found as follows. Replace f of x with y, because you know that f of x and y are just the same thing. Interchange x and y, solve for y, replace y with f inverse of x. So looking here, the first thing we're going to do is take this f of x, and instead of putting f of x, we're going to make it y equals 1/2 x plus 5. Step 2 is to flip the x and y's. This is just taking the x and put it where the y is, and taking the y and put it where the x is. You are not moving any numbers. You are not taking the 1/2 with the x. You literally just take the x, put it where the y was, take the y, put it where the x is. Anywhere you see an x, you're going to put a y. Anywhere you see a y, you're going to put an x. So instead of putting y right here, I'm going to put an x equals. There's a 1/2. You do not change the 1/2. Leave the 1/2 alone. Instead of an x, I'm going to put a y plus 5. So this is technically right now, this is the equation of the inverse of f of x. However, we're used to seeing everything as in terms of y, solved for y. So let's go ahead and solve for y. Solve for y, first step is subtract 5 both sides. So x minus 5 equals 1/2 y. And again, to get y by itself, remember, multiplying by 1/2 is the same thing as dividing by 2. So how are we going to get rid of a divide by 2? You multiply by 2. Now, if you wanted to, you could go ahead and divide by 1/2 and do it in your calculator. But again, knowing what it does, fractions aren't scary if you know what they do. So multiply both sides by 2. Now, when you multiply this side by 2, you have to multiply everything by 2. So this is what happens. Your 1/2 and your 2 cancel, leaving you with y equals, we have this 2 times x minus 5. And we're going to go ahead and distribute that 2, leaving you with y equals 2x. 2 times negative 5 is negative 10. 2x minus 10. There we solve for y. That's step 3. Step 4 is to replace y with f inverse of x. F inverse of x equals 2x minus 10. there is the formula for the inverse of f right there. So we determined whether f of x was 1 to 1. We did. It passed the horizontal line test. Then find its formula. And there's a formula of f inverse. Let's try another example. Determine whether the function x cubed plus 2 is 1 to 1. If it is, find the formula for f inverse. So we need to decide whether it's 1 to 1, we do the horizontal line test. So I'm going to go over here to my calculator, go back to y equals. I already have x cubed plus 2, so I'm going to go ahead and turn that one on. And then graph it. There's x cubed plus 2. Anywhere that you draw a horizontal line on this graph, it's going to cross the graph exactly one time. Now let me draw this one because this one gives a little bit of confusion to people. When you have this, it does flatten out in the center, but if you zoom in right here, you really will only pass the graph one time. It ends up looking more like this when you zoom in right there. So promise, if you have an x cubed, it is 1 to 1 every single time. So that's saying f of x is 1 to 1. That means we can find the inverse of the function. So that tells us it tells us that the inverse f of x is a function. And those two things both occur because f of x passes the horizontal line test. Now let's go ahead and find the equation of the inverse. So we have f of x equals x cubed plus 2. The first step is to change f of x to y. Y equals x cubed plus 2. The second step is change x with y. Anywhere you see an x, you're going to put a y. Anywhere you see a y, you're going to put an x. You do not change anything else. The cube will stay there. We will not touch the cube. You're not going to touch the plus 2. So instead of a y right here, I'm going to put an x equals. Instead of an x, I'm going to put a y. That y is still cubed, and there still is a plus 2 at the end. Now we're going to take this steps and solve for y. So if we want to get y by itself, the first step is to subtract 2 both sides. X minus 2 equals y cubed. Now we need to get rid of the cubed. The opposite of a cube is a cubed root. Remember, you do not have to put plus or minus for a cubed root, only for even roots. So I'm going to cube root both sides. I have the cubed root of x minus 2 equals the cubed root of y cubed. Remember that the cube root and the cube cancel out, leaving you with y equals the cubed root of x minus 2. That's our inverse. Now we just need to denote it as an inverse using our function notation. F inverse of x equals the cubed root of x minus 2. There is the equation for our new inverse. Example number 6. Determine whether the function f of x equals 5x squared minus 2 is 1 to 1. Then, if it is, find the formula for f inverse of x. Go ahead and go in our calculator. You should know what this looks like. It's an x squared, so it should be a parabola. The 5 is positive. It should be facing upwards. The minus 2 means move down 2. But if you don't know what that looks like, you can go ahead and go to your calculator. I already have it written in here. I'm going to turn it on and graph it. There's our parabola. Now remember, to decide whether this function is 1 to 1, you do a horizontal line test. So, horizontal line test, I have a parabola that looks like this. Anywhere that you draw a horizontal line, it's not going to pass. So this tells me that since it fails the horizontal line test, this tells me that f of x is not 1 to 1, and f inverse is not a function. F of x is not 1 to 1, so f inverse is not a function. Since f inverse is not a function, we are not going to waste the time to find the equation for it. So right here, you would just click the box on MyMathLab that says this. It probably will say this. It might say that f inverse is not a function, but f of x is not 1 to 1, so it says if it is 1 to 1, find the formula. We don't have to find the formula because it's not 1 to 1. The next two are your turns. So you go ahead and work this first one and choose the correct answer, and work the second one and choose the correct answer. Here's the answer for the first your turn. Now go ahead and work the second one on your own as well.